Hello everyone. uh, in this lecture we'll talk about connecting a sensor to your Raspberry Pi. I know most of you have done a great job in the project so far in phase 2. Honestly, I wasn't expecting that much of work to be done in phase 2, and the quality of the work is really amazing, and how much you guys have made progress toward finalizing your project and get it to work. And I really appreciate, for those of you who bought additional sensors and additional components to what the department have sent you to make things work and make things nicer. So in this class, I will go again, over connecting a sensor to your Raspberry Pi for those of you who are still working in the project and trying to make it nicer and finish it. So we'll look at how to connect a sensor to a Raspberry Pi. We'll study how to use the input and output with Raspberry Pi, and then finally we'll demonstrate creating a Python script to run and detect the sensor functions. Okay. On this slide, we are continuing our introduction to connecting a sensor to your Raspberry Pi. Specifically, as highlighted in the first bullet point, we'll be using a PIR infrared motion detector for this example. Then, the signal output from this motion detector will serve as the input to our Raspberry Pi. Think of it as the sensor telling the Raspberry Pi, hey, I detected something. Conversely, in the third bullet point, as you can see here, I wanted to say that the Raspberry Pi will output a signal. In our case, this output will be used to control a LED, as mentioned in the in the next bullet point. So the idea is simple. When the motion detector senses movement, the Raspberry Pi will send a signal to turn the LED on. Again, the idea of this is very simple. When the motion detector senses movement, the Raspberry Pi will send a signal to turn the LED on. So before we get into the actual wiring, let's take a look to the sensor, to the hardware component of the sensor. And see some some details about it. For example, this is some of the pins that comes with the sensor. This is the sensor name. It is written here, and okay, let me explain some of these pins for you. So you can clearly see like I said, the demo-shaped infrared sensor itself. What's also important are the label pins. You can see these are the pins. The VCC for power, this one, VCC for power, out for the signal output, and GND for ground. So again, understanding these pins, how it works, and what's the purpose of these pins, will make things easier in the following slides. In this slide, we emphasize, on the crucial steps for finding and understanding the data sheet for your sensor. It's important always, to check the data sheet of your sensor. This is a website for the particular for the sensor we are using for the experiment. So and keep in mind, every device has a data sheet. Every device has a data sheet. Think of it as an official instruction manual for your electronic component. And the way to find it, simply, search it in Google. Search for that sensor in Google. Use the chip number to locate some data, and usually this is the quickest way to find the specific information for your particular sensor model. This will provide you, like I said, with lots of information. For example, it could be some power requirements, how the system outputs its signal, and other critical details for proper use. If you look at the data sheet we have in the right side, we can see that the data sheet contains, the description, specifications, applications, and other features. So it looks like it's a very helpful information that you should consider when working with sensors. Make it a little bit more readable. Okay. So building on the importance of the data sheet, in this slide, we talk about specific information that you can expect to find within it. For example, the data sheet, will have, or you will find in the data sheet, some information about the sensitivity and the delay time. These are crucial parameters for motion sensor, determining how sensitive it is to movement and how long the output signal stays active after motion is detected. And as I mentioned before, knowing the pins, know what the pins does, what each pin does. It's essential for making correct electric connections or wiring. In the third bullet point, as you see, this is very important detail. While the sensor itself might need a 5-volt power supply, its signal output that goes to the Raspberry Pi operates at 3.3 volt voltage logic levels. This is compatible with Raspberry Pi, GIO pins, GIO. So this is very important piece of information that you need to consider or think about it when you make the wiring. Applying higher voltage to the Raspberry Pi GPIO pins can cause permanent damage. Always double check the data sheet to confirm the output voltage levels of your sensors. Looking at the image on the right, we see a top-down view of a PIR motion sensor module, it visually reinforces some of the points that I just mentioned before, and we can see the labels for high or low outputs. These are the signal, we call them the signal pins. GND, like I said, this is the ground, and plus power, which is the power input. This is the power input. Additionally, this particular module shows a jumper set. You can see the jumper set, which allows you actually to select different triggers modes, repeat trigger or single trigger. Again, repeat. These jumper sets help you to choose between or select between repeated trigger or single trigger. The potentiometer for adjusting sensitivity and time delay, which were mentioned in the first bullet point here. We spoke about them before. Okay, this slide just show you the physical connection of the Raspberry Pi, which is the central processing unit, like I said, for our project or for the project. You can see the board itself connected to a power supply, connected to power supply, and we can see the breadboard, and we can see the pin, we can see resistors, we can see the motion sensor. In the context of our project, the Raspberry Pi needs to be powered and ready to interact with sensor and the LED circuit, and the LED circuit will be connecting to its GPIO pin. in the following slide, we will see, in the following slides, we'll see how to make this, programming happens, to make this, LED turn on when a motion sensor detects something. Let's talk about the connection again. We mentioned some of this information before, but this is, let's call it some specifics. So getting into the specifics of connecting our PIR motion detector to the Raspberry Pi, as you can see, the first bullet point is reminding us about the 3 pins we have. I already mentioned them before, and then the signal out, again, just to remind you, this is the pin that outputs a signal, either high or low, depending on whether a motion is detected or not. In this bullet point, this bullet point means, we will be using the Raspberry Pi own 5-volt and ground pins to supply the power to the motion sensor. It's crucial to ensure that the voltage, again, provided by the Raspberry Pi is compatible with the sensor's requirement to avoid damage. The signal out pin of the PIR sensor will be wired to the GPIO pin number 4. So the motion detector signal lead is connected to GPIO 4. Again, this means, the signal out pin. This is the signal out pin of the PIR sensor. Signal out. This one. So the signal out pin of the PIR sensor will be wired to the GPIO pin number 4. The LED indicator circuit is connected to GPIO 16. This means the positive leg plus. This means the positive leg of our LED. The positive leg of our LED is, which is part of a simple, indicator circuit, will be connected to GPIO pin number 16 on the Raspberry Pi. This is one of the output pins that our Python script will control. Okay. The resistor is essential to limit, the current flowing through the LED and prevent it from, burning out. We have mentioned this in previous, video. And to complete the LED circuit, the negative leg of the LED, needs to be connected to one of the ground pins on the Raspberry Pi. On the Raspberry Pi. So now we have discussed the hardware connection. In this slide, this slide introduces the software side of things. The code that we'll have will serve as a brain that tells the Raspberry Pi how to interact with the sensor and the LED. Thonny is a user-friendly, integrated development environment that often used with Raspberry Pi for writing and running Python code. The logic of the program is very simple for this project. So it's very simple. The code logic is very simple. As I mentioned, before, we will turn on. This is the step. We'll turn on the motion detector and wait for motion to be detected. This implies initializing the GPIO pin connected to the sensor, and then pausing the program until the sensor's output changes, indicating motion. When motion is detected, we want the LED to light up. This means that when the Raspberry Pi receives a signal from the motion sensor, our code will instruct the GPIO pin connected to the LED to turn on. thus eliminating the lid. Finally, after a short time with no motion, the lid should go off. This indicates, our code will continue to monitor the sensor's output. If the signal indicating motion stops for a certain period, the code will then instruct the GPIO pin connected to the lid to turn off. Going to the next slide. So we are kind of transitioning to the actual, in this slide, transitioning to the actual Python code we will need to write. In this slide, we outline the necessary libraries that we will import at the beginning of our script. As you can see, we are saying, as you can see in the description of this slide, in the description in this slide, that this library provides a simple these libraries will provide a simple interface for working with GPIO pins on the Raspberry Pi, making it easy to control components like lids and read data from sensors. The GPIO 0 library conventionally includes specific class called motion sensor that simplifies interacting with PIR. That simplifies interacting with the PIR motion detector. Then we will need lid library. We'll need a lid library. Again, GPIO 0 provides a lid class that allows us to easily turn the lid on and off by controlling the voltage to be connected to the connected GPIO pin. So finally, we will need also to import a pause function so that the program will wait and reset before detecting motion again. The pause function from the signal library will keep our program running and listening for motion events indefinitely rather than exiting after the first detection. So moving into the software setup, this slide explains, how we begin writing our Python code, and as we can see, in the first bullet point, which is a fundamental step in programming for hardware interaction, where we give symbolic names to the physical connections in our Raspberry Pi. We can see in these two bullet points, we are seeing the specific assignments. For example, the first bullet point means we are creating a variable named PIR in our code and associating it with general purpose input or output pin, the GPIO number 4 on the Raspberry Pi. This is the pin where we will connect the signal output from our PIR motion detector. Similarly, a lid equal GPIO 16 indicates that we are creating a variable named lid and linking it to the GPIO pin number 16. This is the pin we will use to control lid indicator light. So by having these declarations, we will our Python code, will be able to easily refer to and control the motion sensor and the lid using these simple names. As we can see here, the motion sensor library that we spoke about before or imported earlier. The motion sensor library has numerous functions, including the following: when motion and when no motion. Okay, so the function methods, these two, are used to determine the output of the PIR motion detector sensor. They allow our Python code to react to changes in sensor states. The next bullet point, means that when a PIR sensor detects movement, the wind motion function will be triggered. The wind motion function will be triggered. For wind no motion, for the wind no motion function, it indicates that after a period of no detected movement, the wind no motion function will be triggered. So these two functions, wind motion and wind no motion, provides convenient way for us to execute specific actions in our code based on the state of the motion sensor. As we can see here, the first line, we are importing some libraries. This is what we import the necessary classes from the GPIO0 library, and so we are importing motion sensor, and we are importing a lid. In the second line, we are importing pose. In the first line, here we are creating an instance of the motion sensor class and assign it to a variable name called PIR. The number 4 again inside the parentheses. Specify the motion sensor is connected to GPIO pin number 4 on the Raspberry Pi, which matches the connections that we have discussed earlier. Similarly, lid equal lid 16, create an instance of lid class, assigns it to a variable or to the variable lid. Again, number 16 indicates that our lid is connected to the GPIO pin number 16. In the following two lines, this is where the magic happens. These lines tell the Raspberry Pi what to do when the motion sensor state changes. When the PIR, which is our motion sensor, detects motion, the wind motion event occurs. And we are telling it to execute lid on function, which turns the lid on. Conversely, when motion is no longer detected, the wind no motion event occurs and we execute lid off, which means turning the lid off. Finally, the last line, which is pause, is the function we imported earlier, and this line simply makes the program wait indefinitely, continuously monitoring the motion sensor and reacting accordingly to the rules we have defined before. These are the two rules. Finally, we summarize the outcomes of running the Python code we just looked at, and suggest further possibilities. As you can see, this is clearly explained the basic functionality we have programmed. The lid acts as a visual indicator of a motion detected by the PIR sensor. You could also modify this example, for other outputs. For example, if instead of just turning a lid, you could trigger an audible alarm, like which is the buzzer. You could use the motion detection as a trigger for software action on the Raspberry Pi. In the last bullet point, for example, we highlighted the potential for creating basic security or alarm system using the motion sensor and the Raspberry Pi connectivity. So this slide actually encourages you to think beyond the simple LED example and consider the many other ways you could use a motion sensor connected to a Raspberry Pi for various projects and applications. So yeah, that's it, simply, and hopefully you guys enjoy it, and you learn from it. I will be uploading these slides to Canvas and uploading the video as well. Thank you for listening.